Okay, good morning 11th class. Today we'll study about merits of Bohr's model. Okay, in earlier video, we have learned about Bohr model of hydrogen atom. Now we have so many merits in case of Bohr model of atom. First of all, you know that because there was a drawback in Rutherford model of atom that he failed to explain the stability of atom. Okay, now in case of Bohr, Neil Bohr successfully explained the stability of atom. The first merit is that one is he explained the stability of an atom. And how we explain the stability of atom? Actually, this theory, okay, help in calculating the energy of an electron in, okay, simple energy of an electron in a particular orbit of hydrogen atom कि किस orbit में, either it's a first orbit, second means first shell, second shell. Okay, so this theory is helpful in calculating what that one is calculating in energy in different orbit, either it's a first orbit, second orbit, third orbit. And for that we have one simple expression. Okay, that one is, just check, this one is En. Okay, that one is E represents energy and this N is number of orbit. Either you can say this N is 1, 2, 3, 4, means if you are taking first orbit, so this N is equal to 1. If we are talking about second one, so it's 2, 3, 4 accordingly, because this represents shell कि कौन सा shell है, किस उसका है. So this En is equal to minus 13.6 into Z square upon N square EV. This one is electron volt. Okay, this expression is for hydrogen and hydrogen like ions only. Okay, reason is, you know, that this model is, Bohr's model is only applicable for hydrogen and hydrogen like atom in which only one electron is present. Means if we are talking about suppose this one, that one is hydrogen, number of electron is 1. So this one is, this formula is valid for hydrogen because number of electron is 1. But if this one is helium, okay, so not valid for helium because in this case number of electron is 2. But if this one become He positive, means somehow if we are able to remove some one electron, so in this case this formula is valid for He positive also. Okay, because in this case also number of electron is 1. Okay, same condition, this one is not valid for lithium. Okay, but valid for Li2 positive because all are hydrogen like atom, उसके जैसे हैं, because number of electron is same. Okay, so this expression is only for hydrogen and hydrogen like ions. Okay, not for other one. Now next one is, this one is electron volt. Now when you convert this electron volt into joule, already explained you how to convert, you know how to convert electron volt into joule. After calculating this, your answer is, that one is En is equal to minus 2.18 into 10 raised to power minus 18. Okay, that in bracket Z square upon N square. Okay, that one is in joule. Now this term, that one is equal to Rydberg equation. One value we know, that one is 107. Okay, that value we have learned. That one is, okay, this one is another value of Rydberg equation. That one is in terms of joule, and that one is minus 2.18 into 10 raised to power minus 18. So instead of this, you can write this expression like this: En is equal to minus RH, that Z square upon N square, that is in joule. Okay, now in this case, N, you know, N represents 1, 2, 3. This one is simple, in which we are talking about which orbit, either it's a first orbit, second, either it's a, okay, it depends कि किस orbit की बात कर रहे हैं. Now this Z, where this Z is equal to nuclear charge. Okay, this Z is equal to nuclear charge. Nuclear charge means, okay, or in simple term you can understand like this, that this nuclear charge means number of protons. Whatever is the number of proton present in an atom, that one is Z. That one is nuclear charge because you know that nucleus, it consists of proton and neutron have no charge. So whatever is the charge, that is because of proton. Okay, so whatever is the number of proton, that one is nuclear charge. Okay, so this one. Now suppose you have to calculate energy of first orbit. अगर तुम्हें you have to calculate energy of first orbit, second orbit. Okay, it's simple. You have to learn this formula and put this value. Just see in this one, it's a E1. Suppose we are calculating energy of first orbit. So simple, for hydrogen, okay, that one is Z is equal to 1. Okay, that one is because the nuclear charge is 1, number of proton is 1. Okay, now in this case n is also equal to 1 because we are talking about first orbit. If you will take second one, so here it becomes 2 square. Now after solving this, obviously simple, your answer is minus 2.18 into 10 raised to power minus 18. Like this you can solve for E2 means second orbit, third orbit and so on. Okay, now just see in this one, this negative sign is there. When you calculate this value, energy for first orbit, second orbit, that negative value is there. This shows what? This negative sign indicates the stability of an atom. Okay, why? Because when negative sign is there, so this shows what? That energy is required to remove the electron. कि हम उसे energy क्या करेंगे? Provide करवाएंगे to remove the electron from their orbit. Okay, that's why this negative sign indicate what? That one is stability. Now suppose in this case, so that one is in this case now. Okay, now suppose in this case energy, or either you can say in. Okay, now just see. Suppose in this one, if n is equal to infinity, means that orbit electron is just see in this one is n is equal to infinity, means कि orbit आपका कैसा है, न्यूक्लियस से बहुत दूर चला गया. In that case, that En is equal to 0. Why? Just see, when you put this infinity value here, okay, it means when you put this infinity value here, so infinity means the number is very large. So in this case, when you solve it, so your answer is approximately 0. So in that case, En is equal to 0, and at this stage, that electrons are free from the influence of nucleus. Okay, now this one is regarding to merit of Bohr model. Now Bohr model help in calculating radius of the orbit. Okay, just now in this one, that another merit we have, that Bohr model helps in calculating radius of orbit. Okay, now energy, for formula for calculating energy of different orbit. Okay, that one also we have done. Now this one is again, this theory helps in calculating radius of different orbit. But again, this one is again valid for hydrogen and hydrogen-like atoms. Now just see in this one, so the radii of the stationary states are expressed as, again we have another formula, that one is Rn is equal to n square a naught. Now we have a fixed value of a naught in terms of picometer. You can convert it up also. Okay, now just see, a naught is equal to 52.9 picometer. Now suppose you have to calculate for radius for first orbit. अगर first orbit के लिए calculate करना है, now this one is n is equal to 1, 2, 3. Okay, it represents what number? That one is it represents orbit as it's the first, second, third. Now 1 square into 52.9. That one is your answer is 52.9 picometer. Maybe your question is you have to calculate radius for first orbit of Bohr model. Okay, so accordingly you can put value and solve. Now if you have to calculate radius for second orbit, it's a 2 in square, because again in this one second orbit n is equal to 2, so 2 square into 52.9. Okay, either you can write first formula a naught, otherwise you can put direct value. That one is 52.9. That's a 2 into 2, it's a 4 into 52.9. After solving this, your answer is 211.6 picometer. Okay, now this one is for normal expression. Now suppose this one is for hydrogen. Now if you have to write expression for hydrogen like atom or ions, so for ion, in case of this, for ions like He positive, Li2 positive, so we have an expression, that one is Rn is equal to 52.9 into n square upon z. This one is another formula. Okay, but that one is for ions. For simple one, hydrogen, this formula, and for ions we have another formula. Now another merit of Bohr model we have, that one is this model explain atomic spectrum of hydrogen. Okay, and how we explain that we will study in another video.